Good afternoon, everyone. It's a pleasure for me to explain our project in this winter school section. Our goal is to implement the MATISSE tool in the planetary geology. Before telling you about this tool, it's important to introduce the Space Science Data Center. ASDC is an office of Italian Space Agency. It's a center for scientific operations, data processing, and data storage that provides support to several space missions. The Space Science Data Center was born as a center dedicated of observation of the universe, mainly high energy, and over time a group that mainly deals with data coming from the exploration of the solar system was added. Currently, ASDC deals in other topics like stellar astrophysics, cosmology, astroparticles, and cosmic rays. And Earth observation about this topic is in definition. In particular, ASDC has also result of collaboration between research institutes such as the National Institute of Astrophysics and private companies such as Telespazio. And thanks to this synergy, we have in-depth knowledge of methodologies and practice adopted by researchers in the space field. For this, we are committed to acquiring, managing, processing, and distributing space mission data, following the FAIR principles, according to which the data must be findable, accessible, interoperable, and reusable, in order to guarantee the high quality of the data. ASDC also provides a specific tool, interactive tool for access and the use of data coming from some missions. In the 2012 was created the multi-purpose advanced tool for instruments for the solar system exploration. This MATISSE tool is written in Python 3, and currently we have a 2.0 version available at this link. In July 2019, MATISSE also earned a place on the cover of Nature Astronomy magazine, thanks to a work on Comet 67P. At this figure on the cover, you can see one of functionalities of this tool, that is the possibility of visualization of 3D models of small bodies. MATISSE also have other topics, other functionalities, for example, visualization of data directly from the tool and visualization of thermophysical model for airless bodies. But today we will focus on a new functionality. In fact, in these years, we implemented the use and interest of MATISSE tool for geology community with the insertion into the tool of geological maps of some bodies of the solar system. Before telling you about this functionality, it's important to tell you that to explain the database of MATISSE tool. In particular, it was necessary to modify the database of this tool. In fact, previously we had a MySQL database that is a generic database without geospatial information, but at version 2.0, we have a Postgres and PostGIS database that allows you to define geological units in a specific reference system. Also, currently in this version of MATISSE, we have a user-friendly interface. In fact, previously in the old version of MATISSE, we had static images that you just downloaded, but now we have a FITS file that already from the web page you can start editing and analyzing. We have a servlet based. In fact, it's possible to execute complex queries by command line, and you can download a large amount of data directly from command line. And there is the possibility to study the geology compare with a thermophysical code. Okay, now let's go to see in summary the methodology to upload geological maps into MATISSE database. Thanks to collaboration with PlanMap and GMap teams, we started to upload it in the MATISSE database some geological maps of some bodies. For example, in the last years, we uploaded Mars, Sirius, and Mercury geological maps. First, we uploaded these geological maps into Geographic Information System software, and we extracted the polygons of each geological units, and we uploaded them into MATISSE database by a Python code. It was also necessary to do to create tables that contains all parameters necessary for MATISSE to search and selections of geological units. In this slide, you can show the initial screens of MATISSE tool for Mercury, Mars, and the Sirius surface. The user can select the target, for example, Mercury, the missions and instruments. Then the user can draw the area of interest in the global map, and automatically MATISSE through a drop-down menu show you all geological units that are mapped in your area of interest. This approach is very flexible, and we can use all geometries of geological maps regardless of the dataset we want to analyze. Okay, now let's see some examples. In this first example, I selected Sirius target mission known, and I selected the Occator craters on Sirius surface. Automatically, MATISSE show the geological units that are mapped into this area. We uploaded in the MATISSE database the geological map of Andrea Nass in 2023, and these are all geological units that are inside your area selected. For Sirius, as I told you before, it's possible also to study the thermophysical model of the surface. With this study, it's possible to understand how the surface temperature changes based on the type of soil. In this second example, there is a Hokusai crater. Hokusai crater is a crater mapped inside the Hokusai quadrangle on Mercury's surface. We selected all parameters, target missions and instruments, and MATISSE found all geological units that are mapped by Jack Wright in this selected area. For example, we select smooth plains materials, and the result of the first query is a table of all observations that MATISSE found with the insertion of your parameters. And this is the last result of your it's the result of the smooth plains materials. You can download feeds format, or you can analyze it directly from the tool without download data. What are our future work? We will add also dataset of moon surface. In fact, we decided to integrating in MATISSE tool the global geological maps created by lunar planetary system, and for this, it's important to have for MATISSE, it's important to have a lot of planetary bodies to study the geology of planetary of the moon. Moreover, we will add other data set. For example, we are inserting to MATISSE database also the possibility to view the context camera data of Mars surface, and also the possibility to download not only the FITS file format, but also the TIFF format that you can download and upload in your software. Okay, for MATISSE, it's important also to have other functionalities. In fact, we decided to add into MATISSE tool also the possibility to search a specific area of interest. For example, a specific crater, like in this figure, the Firth crater, for example, on Mars surface, and also the quadrangle or area, specific area of interest directly from this drop-down menu. Moreover, we will add also other information. For example, we will add also the spectral map created by PlanMap teams, and also the high resolution DTMs. And of course, we will add also other data set, for example, Baby Colombo for Mercury, for the study of Mercury surface, and Cassis or CTX. Thank you for your attention.